What do we think? So not necessarily trying to get all the way to what the answer might be, just will there be an actual answer? Do I need to work on trying to find it? Can we solve this thing?
Yeah.
Yeah, we absolutely can. What would be our first step in trying to solve this thing? Subtract 5. Absolutely valid. We could 100% solve this thing and get to a real answer. I have just x on one side. I'm not getting anything crazy. I could take this and we could do it. 3x plus 5 equals 11. We would subtract 5 from both sides. We would then have our 3x equals 6. So what would our x be? 2. So we can get this one all the way down to a solution. That's our answer. X is 2. What about b? Could we get a number for x here?
No.
Why not?
You would have to take the square root, right?
Mm-hmm.
But we can't take the square root of x. I mean, we would have to do the square root of x, right?
We'd have to do square root of both sides, right?
Yeah.
So if we wanted to do that, I mean, we could try.
10 is the average square root, though.
But it's okay to have decimals. So if we had something like this, I wouldn't want to square root it when it's like this with the plus on there. But
Yeah, you can solve it.
I could take this and I could make this x squared plus 1 equals 10. And I could subtract that 1 to make x squared equals 9. What number when squared is 9? 3. Or, what else when squared gives us 9? Remember?
81. Very nice.
That would be 9 squared.
Yeah.
Think smaller than 3.
0? Negative 3?
Negative 3.
Okay.
Negative 3 times negative 3 also gives us a 9. So this one has 2 answers. Sometimes, when we have squares, a lot of times we'll have 2 answers.
X equals plus minus.
It would be plus or minus 3. So we could, again, get a solution. And in fact, we have 2 solutions on this one. That's pulling up some memory on Algebra 2 is the last time we did that. But what we really have here is we have something positive plus 1 can get to a positive number. Absolutely fine. Because whenever we have something squared, we can't get a negative number. There is nothing in the real world that will square and be negative. So is there a positive number that I can add to 9? That'll give me a 1.
You said subtract 9?
Is there a 9? It says this is a positive number. Whenever we have a square, that's a positive number. So is there a positive number I can add to 9 that's going to equal 1? No. This would give me something that's imaginary. We're not going to have to deal with imaginary numbers, but like it's a thing that exists. But so this is not going to have a real answer. No real solution. Because there's not a positive number that I can add to 9 that's going to give me a smaller number. What about something like D? What do you think about that? Is that going to have an answer? Look at that one. Okay, 3x minus 5 equals 3x plus 6. I'm just going to box this one. This one goes with this. What do you think about this? What do we notice about it? You can add 5 on both sides. That's going to give us, I'll bring it down here, our 3x minus 5, 3x plus 6. I can add 5 on both sides if we want to do that. That'll give me 3x equals 3x plus 11. That's an 11. What can we do there? What do we notice? What do we think? What's this one down here? Either what could we do or what are we noticing? neither of which will be on our phones. 1, 2, 3, 4, 5, 6 of us.
On E,
No, we're still looking at D. We never finished it.
divide 3. Well, no, you subtract 3.
Why? I heard it something in the back. No solution. Why?
Cancel out.
My x's are going to cancel out. If I subtract 3x from both sides, we're going to get 0 equals 11.
Yeah, I meant,
Ugh.
Dividing would cancel it out here, too.
Say it.
Dividing would cancel out as well.
Dividing by 3 won't cancel it out because technically that just gets rid of the 1 in front of it. We still have an x and an x. So we would want to get our x's on the same side. But if we look up here, think of this as a mx plus b situation. I've got mx and an intercept at -5. Slope of 3. Slope of 3, intercept at 6. Those are parallel lines. I have the same slopes and different intercepts. So those would be 2 parallel lines. These aren't going to cross ever. If I subtracted 3x from each side right at the beginning, I'd get -5 equals 6, which again is something that's not true. So this is another time when we're going to have no solution. This is false. No solution. So we can absolutely start trying to solve stuff to see if we can spot if it's working or not. Sometimes we can look at the shape of stuff and try and figure it out. So let's look at E, because E's a little weird. We want to know if there's any way I could get these two statements, x plus 4 and 3 plus x, that are in a fraction. I know we're super fans of fractions. Is there any way those two divided is going to make a 1?
on E,
On E.
divided to be 1. Yeah, you can do negative numbers.
It could be negative numbers, but would that matter? What about this one? I'll zoom it in so we can see a little bit bigger, because I know sometimes it's that we can't see in the back. I'm sure that's entirely the reason we're not paying attention. Definitely it's because it's not big enough. I have x plus 4 over 3 plus x. What do we notice about this? Even if we don't look at this, what do we notice about this? What if I switch the order a little bit and put it as x plus 4 over x plus 3? Means the same thing. Good instinct, but it doesn't quite cancel out. But is there, what do we need for a fraction to simplify down to be 1? What does it need to have top and bottom? If I want a fraction that simplifies down to be 1, what do I need to have?
Good question.
Here, I'll grab a marker. Just like in general, with a fraction, if I want it
Oh, so equal 1? It have to be the same
to
number.
equal 1,
Same number on the.
it'd have to be the same number, top and bottom. I'm going to say, so if I had a 2 on the top, I would need to have a 2 on the bottom. If I had a 3 on the top, I would need a 3 on the bottom. So is there any number that I can add 4 to and add 3 to get the same number? Because this is x plus 4 and that same x plus 3.
No.
Even if I added 0, it's not going to get down to the same number because it's just 1x. These two pieces can't equal each other. It's very much the same as how this guy was. I have that same slope, different intercepts. These two pieces aren't going to equal 1. So this one also has no real solution. We don't even have to know what that thing's gonna look like, because it's gonna look weird. But because there's not a number that I can add 4 to and add to 3 that would give me the exact same value, this doesn't happen. You can't do that. If you wanted to try and solve it, you would have to multiply both sides by that denominator, the 3 plus x. So we'd get the denominator to cancel out. We'd wind up with 3 plus x equals x plus 4. That would be how we would try and go about solving it. And we're going to look at f. What do we think about that one? This one's probably the hardest one up here. What do you think about this one? Or at least, what do we notice about it? We have our x minus 1 in the numerator. Just look at that denominator. What do we notice about that?
I think 200 minus 2.
If they're both been multiplied by 2. So I could rewrite that denominator in its factored form. Oh, snap, pulling that back from last chapter. What? Well, I could put it as 2 times x minus 1 what would happen here? This would be a remembering from algebra 2 situation. Do you remember what we could do here? If I have the same factor on the top and on the bottom,
Go 1.
it becomes a 1. These two pieces cancel out. We can only cancel out stuff that is multiplied or takes up the whole thing. So this would actually simplify down to be a 1 over 2. Does that equal 1? Question mark? Does it equal 1? Because that's what they said here. Nope. Again, this is a no solution situation. So we have a lot up here that don't have solutions. We, in fact, had 2 that we could get solutions on. Bless you. The rest of these were no solutions. It doesn't happen. So sometimes we need to look carefully at our equations because it's going to be stuff we don't know what to do with. More often than not, it will be stuff we can solve, but it's really important that we can start looking at the equations and maybe not necessarily needing to solve all the way down to it. Trying to start looking at them without getting all the way to an answer. Because what we're going to do today is we're going to look at a page in our workbook that has 6 equations on it. And we want to know which ones of them have the same answer. Because there's only 3 different answers on this whole page. And we want to try and match them up. Which ones have the same answer and which ones don't. So what we're going to be doing is we're going to look at page 82. And we want to see if we can figure out which of these 6 equations are going to have the same answer. Now, we absolutely could come through here, solve everything, and just find the answer. But that's a lot of work for all 6 of these equations, because they're not particularly pretty. In fact, some of them are kind of ugly, especially number 6. It's on page 82. So what we're going to do, and what I want you guys to do, and you guys can work together on this, or you can work by yourself. But I want you guys to try for a good 10, 15 minutes. Oh my gosh, what's up? A good 10, 15 minutes.
We gotta solve it on the page.
I was like, it's page 82. I want to know which of these are going to have the same answers. You could get all the way down to answers and just look at them. Or we can look at the shapes of the equations and see if we notice things. So page 82. So I want you guys to look at them. We'll come back and talk about it in a second. I'm going to come circulate around. This is not school-sanctioned TikTok time. This is not school-sanctioned Instagram time. This is not YouTube time. This is page 82 time. Thank you. Okay, so give these a shot. See what we can come up with. Take a peek at them. If you want to get all the way down to solving, great. And if we want to do it slightly differently, also great. When we get to the point where we're talking it through, I will show you what they're trying to get us to see.